But nevertheless, it is a really hard concept, I think, for those of us who are not scientists to get our heads around. As far as we know, the Earth is the only planet in the whole universe, as far as we know, that actually has intelligent life on it, or any kind of life that we're sure of. And the chances of that happening seem to be so infinitesimal. Why should that be? Can you at least understand why people who are prone to a theistic interpretation of life might say, well, look, isn't that just too amazing to have just happened by chance? Doesn't that sort of indicate that there's a God who wanted it and created us, created Earth with the moon in the right place and with Jupiter in the right place and with a friendly sun and a friendly solar system and all the rest of it?
Yes. Well, there's no doubt that our situation on this planet is comparatively friendly. I don't wish to concede at all that that is only one life form in the universe. I think it's probable that there is quite a lot of life in the universe. I think it's probably a very rare phenomenon, which means that any one of these little islands of life is probably rather unlikely to encounter any other of these islands of life. So it may be that all islands of life are blissfully unaware of each other's existence. It's a genuinely open question how rare life is. Now, let's go to one extreme and entertain the possibility that this is indeed the only planet in the entire universe where there is life. And then we have to say, well, what can we deduce from that? One thing that Paul has just pointed out is that we can say that this planet has certain very friendly properties. It's exactly the right distance from a star, from its star. If it was, it's the so-called Goldilocks zone. If it was, it's Goldilocks in the sense of just not too hot, not too cold, but just right. It's in the Goldilocks zone in the sense that if it were any closer to the sun, all the water would boil. And if it were any further from the sun, all the water would freeze. So there's quite a narrow band of orbits in which water remains liquid, which we need. There's also the moon, which has a certain stabilizing effect, which makes it possible for life to, or makes it easier, at least, for life to have evolved. There's Jupiter, which acts as a great big hoover to stop too many asteroids hitting us. Some do, nevertheless, but it's rare. One of the reasons is that Jupiter's there, acting as a great gravitational sink, pulling these missiles away. So there is a lot going for us in this solar system, and so there damn well has to be, because we're here. I mean, obviously, even if we're the only form of life in the universe, we would have to be, that the one planet where we are would have to be a planet which has those favorable characteristics, however rare such a planet is. Now, knowing, we don't know, but calculating, speculating, well, more than speculating, it's an informed calculation about how many planets there are in the universe. There must be actually a very large number which have at least those complaisant properties friendly to life. It may still be that only one of them actually has life, and that has a very interesting consequence, which I perhaps briefly explore. If anybody wishes to say that this is the only planet in the entire universe which has life, then a consequence of that would have to be that the origin of life, the chemical circumstances that gave rise to the first self-replicating molecule, the first proto-gene, the origin of life would have to be a quite fantastically, stupendously rare and improbable event. Because if it were not stupendously rare and improbable, it would be in lots of other planets as well as this one. So if we in theory imagine a spectrum of possibilities where on the one hand there's lots and lots of life all over the universe, on the other hand there's only one. In other words, on this end, the origin of life is a fairly probable chemical event. On that end, it's a colossally improbable, a stupefyingly improbable event. Nevertheless, because there are so many planets, stupefyingly improbable actually means it only happens once in the universe. And with hindsight, this is the so-called anthropic principle, with hindsight, that one planet has got to be this one, because we are the ones talking about it. We are the ones sitting here thinking about it. And so the anthropic principle is a very elegant, beautiful idea, because it has this curious paradoxical effect that it allows us to entertain a hugely improbable event and still come up with a satisfying, complete explanation for our own existence. And it's even possible to twist that argument further and say that because we've never actually been visited, as Enrico Fermi said, where are they? Because we've never been visited, you might deduce from that, or never even been visited by radio waves from a distant planet, you might deduce from that that intelligent life, at least technological life, is indeed very, very rare. And therefore, if it were easy for us to understand the origin of life, if chemists could come up and say, oh yeah, easy to see how life could originate, it could originate in this way or this way or this way, we should be positively worried. Because if it's easy to think of how the origin of life happened on this planet, then there should be lots of other planets where it happened as well. So one corollary of the where are they question is that if there is life elsewhere in the universe, it's got to be non-technological life. Technological life has got to be rare, which means that either the origin of life itself is very rare, or the origin of life is allowed to be common, but the origin of advanced, intelligent, technological life has got to be very rare. Somewhere along the line, you've got to interpose a sort of wall of improbability in order to explain why we have never been visited.